Everyone, my name is João Palma, and I'll be presenting some of the work being developed on the RTU technology project, which is a modular construction project that is developed in Portugal. And I'll be talking about the topics of how blockchain and how digital products passports can be used to empower the circular economy. So a little bit about the motivation behind this work. I'm not going to talk too much about the upper part, not because it's not important, but because I think that by now everyone is aware of the environmental burden of the construction sector. But I would like to talk about these two measures that are applied in this project, which is the design for the assembly. So these modular units are designed in a way that have in mind the end of life cycle, so that they can be easily disassembled, recovered, recycled, and reused. And the second one is the digital product passport, which is basically a somewhat new concept that was introduced last year by the ESPR, the Eco-Design for Sustainable Products Regulation. And this is basically the identity cards of products and materials. And this is very important because a lot of the waste that is generated in our industry is not necessarily products or materials that are of low quality, but are products or materials that don't have that data. Their data is unknown. And because it's unknown, it cannot comply to regulation, and they go to waste. And we believe that these passports will be able to give this much needed identity. So a quick overview of the objectives that we're trying to accomplish. It can be broken down into two components. The first is the DPP platform, which is a web-based platform that uses blockchain to manage passports along the life cycle of the products. And then we have also a BIM plugin for BIM monitoring software that is broken down into two parts. The first is the BIM library, which is a standard BIM library that complies with European standards. And the second is the LCA tool that basically does automated LCA at the model level. And this LCA tool is compatible with the data structure of the passports and of the BIM objects that are offered by the BIM library. And so overall, what we're trying to achieve is basically provide tools to manage, for the stakeholders to manage their passports data throughout the life cycle of the products. And then when they reach their end of use, we can feed this data directly to designers through the BIM monitoring software so that they can import this data into their models and give a new use to these reusable products. So starting with the DPP platform, this is a decentralized application, which means that the user can use their blockchain wallet to log in, and the passport is broken down into three levels: the building level, the modular unit level, and the component level. So here you can see some of the data that is available on the passport: properties, files that are required by the ESPR, and then the building passport has the modular units in it, and the modular units passport has the components in it. It's this nested structure of three levels. And the user can also see the LCA, the environmental data, broken down into the different LCA stages, and into pie charts, which show the contribution of the lower level element to the upper level element. They can browse and see the data of the modular units, and inside the modular units of each component that composes this modular unit, and see the breakdown of the environmental data. So these passports are shared with using tokens, and these tokens are associated with roles. So here I am setting up a role called sustainability, and I'm going to select the sustainability option so that I grant access only to the sustainability data. So I'm saving this role into the smart contract, and if I go to the sharing center of the passport, I can associate this role with a token. I'm associating the sustainability role with a token, and I'm going to send this token to another user, and that user will have access only to the data that is permitted by the role. So I'm sending this token to another user, and in a short while I will be logging in into that other user's account, and we will see that the passport has been successfully shared, and that only the data that is associated with the role can be accessed. The rest of the data is encrypted and cannot be accessed. So I'm logging in into the other account. I can see that the passport has been shared, and I can also see that only the sustainability data is available. The rest of the data is encrypted and not accessible. And this is very important because this data is very valuable to economic operators. They are very hesitant to share this data, and we have to make sure that we provide them tools that safeguard that this data is only accessible to them or to authorized personnel that they deem access to, and only the specific part of the data that are associated with the role. So the platform also has a validator. So if we go to a passport page, we can download the structure, the file of the passport, which is a JSON file. And if you drop it in the validator, we can see that the passport is valid. And if I open the file and I tamper with the values and change manually some of the values, if I drop this new file into the validator will tell me that it's not valid. And it does this because every time there's a new version of a passport, the platform computes a hash of that data and stores it in the smart contract. So when people want to perform validation, they can drop a file. The platform will fetch the authentic hash of that file, compares both hashes, and if the hashes matches, then that means the passport is valid. If the hashes don't match, then it's invalid and it's been tampered with. So the platform uses 5 smart contracts, which is the custody token and the permission token contract. Basically, the custody token grants ownership of the passport, and there's only one token for each passport. And whoever is the holder of this token can create multiple permission tokens and send it to other users to grant them access to the data. And as I said before, these are associated with roles, and they can specify exactly which data they want to grant access to. There's the roles contract that stores the user roles and the configurations of these roles, the versioning contract, which I talked about in the last slide, and the main contract, which basically holds the data about the mappings between the passports and the custody tokens, the passports and the permission tokens, the mappings between the permission tokens and those roles, and they can also mint tokens, verify passport ownership, and establish or revoke these mappings. So moving on to the BIM plugin, the first part is a BIM library. I'm not going to go into much detail about the BIM library because it's a standard BIM library. There's nothing really special about it. The only thing that I want to focus on is the passport section. So every product in this BIM library has its own section. And in this section, there's a passport that designers can go and see passports that are related to this product. So they can visualize the data of the passport in the same way as in the platform, the DPP platform, and they can select multiple passports to compare them with each other and see very quickly which one has the best environmental data, which one best fits the project requirements, and then once they selected a passport, they can easily import this data into their BIM model and select exactly which type of data that they want to import in order to avoid bloating the model, because not all information is needed at the same time. So finally, there's the LCA tool. This tool performs automated LCA at the level of the model, and this is possible because it is compatible with the data structure of the passports and of the BIM objects that are offered by the BIM library. So the user can quickly see the environmental data broken down into LCA stages, the contributions, and you can see also the data of each type of element. They can choose roofs, walls, doors, and sometimes this data is not very easily to analyze numerically, so the platform also provides ways to create 3D views which are colored and give a more qualitative valuation of the data. And this way, the user can quickly see which elements may have a bigger environmental burden, which ones may be a more environmental friendly. So here is the result of the 3D view, and this way the user can quickly see which ones are better and which are not from an environmental standpoint. So in conclusion, these passports are very important to bridge lifecycle information gaps, which is very important for when a reusable product reaches its end of use to have a new use, because, as I said in the first slide, most of the products that go to waste, they go to waste not because they are of low quality, but because they lack information. This way we can store this information. Blockchain technology enhances traceability and transparency, which is very important for regulators. Transparency is very important for regulators. And this transparency does not mean that that the data privacy is not safeguarded for economic operators, because, as I said before, this data is very valuable, and we must grant the means to make sure that this data is only accessible to them or to personnel that they deem to have authorization for this data. Standardization is very important in the context of this work. It allows for the automated LCA, because the properties are standardized and they have global unique identifiers, so they are machine readable, and the LCA tool can read them and can understand what they are. And finally, we hope that this system can improve circular economy practices by making very easy to access passport data directly in the BIM authoring software, for designers to very easily have access to this data and import this data into their BIM models, so that they can find new uses for these reusable products that are for sale in the secondary markets. So thank you very much for your attention, and if there's any questions, I'll gladly take them.